Hi there, welcome back. I was just having a look at this thing here, and I'm getting rid of everything else. What ends up in the debug directory are these 4 files to do with some DLL, 2 of which I don't want. Now I can set them to go off somewhere else, but I just don't want them. So I can figure out how to turn them off. There's something called maybe linker. Link library depend. Register output. Ignore. Yes. Let's try that. Clean everything. It did create them again. One of the things I removed. Okay, ignore input. That's linker type. How about this? Maybe no. Oh wait, I know. Maybe. I mean, I can send them off to nowhere, no man's land. That's true. However, here's where it's supposed to go. Well, the lid part anyway. I don't know about that EXP file. So let's just can I say none? Nothing. Okay. Still making. Well, it's nice that it made them, even though I didn't ask. They're going to go into the intermediate directory. Int dir. Int dir. You can call them anything, but I'll give them their usual name. Should be the project name. Now, int dir doesn't have a slash. Project name. Some of them have slashes and some don't. They shouldn't have slashes generally. How come I can't see it? Project name. Oh. Okay. I need that file for this. DLH, whatever. Delster. It's like my Durster. Alright. Can't read it. Can't read it unless it's uppercase. I found out that I don't have to worry about all those quotes and removing and adding them back. This seems to work. I haven't found a case where it doesn't work. Because if there's quotes, it allows this, like a quote, blah blah blah, as long as the quotes are matched. Okay, down. No, that's not, the other one does /s, but I don't want to do that. Maybe I should. No, it's too dangerous. However, I could say %2. No. Alright, now let's build our DLL. That's all of 2 files that I want only. The DLL and the PDB, and no import library, no lib file, and no exp file. They've been built, but they've been tucked away into the intermediate directory, which I don't care about. Okay. Now, okay, I don't like the name of this function either. I want to make this different slightly. Let's call this add. Let's make up our own name block. Add integers. And then we'll have another one for floats. Signed. Now, does it matter if it's signed or unsigned? That's a puzzle for you. There's another puzzle for you. How many bytes in a float? How much it's going to put it? You'll notice before I got rid of that thing, and now it doesn't say it anymore, does it? I want the simple printout. I want that @ sign. It's telling us it takes 2 ends. But I want an @ I want numeric. I want to dump in and some switches. I gotta change the name just to see. So dumb. I can change it back. When I get rid of all that type information that dump bin loves, then it has no choice but to tell me what the exported name is in terms of it has to say how many bytes it takes as an argument, because in the Pascal calling convention, it is the responsibility of the function itself to do the cleanup. So the linker knows the function knows how much to clean up. So therefore dump bin knows. Now here is the puzzle. Add floats. Question is, what should we return a float? I could make this into a template, but F1 plus F2. How many bytes is one float? Okay. Now the answer is currently being placed into that DLL, and I'm going to ask you. Add floats is going to have an at sign after it, followed by a number of bytes that it takes in arguments. Half of that is the number of bytes in one float. How many bytes is that? That's your question, your puzzle. I'm going to pause this. Now, if I could, I would play music, but I'm sure that the police would come after me. But and even if I hummed it, it would become a match. But there's a television show called Jeopardy, and that's the music that would be played at this point for about the next 5 minutes. Actually, 10 minutes. No, 5 minutes. Okay, so from 44 to 49, I want you to come up with that answer without compiling anything or looking online. Okay, now that became quite a long diversion, and got us off the topic. So what I did was I cut out the diversion, and you can see I'm uploading it now, so that it'll be ready by the time you get here in the video. An annotation will show up that will allow you to follow that diversion if you want. Otherwise, continue where we are. Okay, so here's our DLL, and I have two functions. The answer, by the way, is that a float, a real float, is 32 bits, and it always has been. However, floats sometimes get turned into doubles. Just as sometimes things get promoted to ints, floats sometimes get promoted to doubles. In particular, in the case of printf. Okay, so now we have two functions. Anything else we want to add? In our export table, here are our exports. Add integers, add floats. Okay. They should both work fine. What else could we do? Just for fun. No, okay, no, this is of some interest. Suppose we want this, our DLL, and this is something that's important to do with DLLs in general, and also with COM. Suppose we want to, we're tired of our malloc and all that stuff. Maybe some DLLs got a better version. So let's ask it to, maybe we have a function that can allocate some memory and return a pointer to void. Alloc method and take a size height. Okay. Now, no problem. We'll return malloc size. Right? Good enough. If it succeeds, it succeeds. If it fails, it fails. They can deal with the problem. Okay, so add that to the list. Then now size t, because I've turned off any porting issues that were, and this is 32-bit Windows, x86 target, size t is like an unsigned integer. And we're going to need a corresponding free. Now that's the part that I want you to see. Please previously allocated memory. Okay, and that's an easy function to write. It doesn't return anything. So that void star in, and just call free. Okay. So now we have a fully featured DLL with lots of functions. Now let's try some of our functions. First, we want to get the forget about this first. We want to get this first. So I'm not going to be sure of that. I'm going to make any ifs. And maybe I'll make type this. Add-ins, right? That's the meaning of that. Add integers function. This is what a float adder looks like. And this is what an allocator looks like. Here's line up. Here's what I freeze. Okay, so those are the types of functions. Now I can load those all up, hopefully get a set of them. I'll have add integers. Oh god. Thought you can see that, didn't you? I can make this into a macro if I use the same name for the type data as the anyway. And we'll call this our adder. And rows. This will be our f adder. And allocator. Allocator. And release. Let's call it releaser. Release. I don't know if it's ER or OR. OR looks better. Okay, do the ER. So. Free. Let's type free. Let's call it not free or releaser. Deallocator. Oh, that sounds good. Okay. Here's all the stuff. Now, if all that works, got a lot of things that helps me find mistakes. Add integers, add floats. Allocator, free, deallocator, free mem. Okay, how about this? Now these are getting the actual process. Functions. These are the names of the functions. I'm going to do this. I want a bunch of ints. At 10 times the size of the int. Okay, that should give me pointer to 10 ints. With 10 times. But I don't want to lose where I was. Oh, I can easily get back to it. I need a count. This thing's never been any use. To get back to the start, I just got to subtract 10. Right? That should take me back to the beginning. I incremented it 10 times, take away 10. Or let's say 7 equals 7. That way we know we haven't gone out wrong. Okay, now let's do the same loop and print them out. Let's start here. Same thing again. Post increment. So we do that and then at the end print it. Final character return. So we should print out the numbers from 0 to 9, right? In a row, and then character return here. I don't need it, but I'll put it there. And there should be no crash and no problem because it's allocated to memory. First, no, I should also have assertions on all these. That's why a macro is good for this part. Chord keyboard required macro. I'll go away. Oh, wait. It worked. Can't seem to hold shift down. Okay, again, everything is inserted. Put it all in one spot. And the only one I'm using is allocate. First time. We'll run a little debugger. Okay, fixing the bug. So just as with malloc, you gotta cast things properly. And this should have been 4. And that's true. All of these need HDLL. Okay. I run up to here. Now, everything, nothing. Here are the addresses of the functions. 10, 20, 40, and 60. Okay, now they've been loaded into memory already. I could go to those addresses. And I go to it as code. I don't want to assemble it. I would have to do that. But anyway. One, okay. 1, 3, 0, 1, 0, 1. 1000 times 10. Oh, there it is. There's a function there. 20. Here's another. Now, if I could unassemble it. Whatever. Okay, call the allocator. It returned a value. Storing 10 values. And unlike assembler, subtracting 10 means to subtract 10 of its type away. And see, that's true. The assertion is correct. So now I'm going to loop 10 times. D to maintain the value. Print carriage return and run. Great, perfect. You'll also notice that I don't even have a memory leak. This here, this is better than malloc. It frees itself. There's no memory leak report. Of course, that's not true. The reason we're not getting a memory leak report is because this allocator is not the same as our malloc. It's the same function, right? Let's step into this. Okay. Here we are. Now this is all quite familiar. But look where we are. MSVCRT80D DLL. And where is that? That's this DLL here that got loaded when we loaded that. So therefore, even though this is a debug malloc, right? And it's like it's got block number, file name, line, and a debug heap, and it's keeping track of all this stuff. It's all variables that are only have any meaning in this runtime library, not our runtime library. Right? As far as our runtime library is concerned, nothing's happened. If I put if I just change it a different one, same idea, I'll use malloc. Now I'm gonna get a memory leak report because just a minute. I'm gonna get a memory leak report because that report pertains to my heap. Now where am I now? See, I'm still in utest, right? I step into this. I'm always in utest. Why am I in utest? Because this utest contains its own runtime library statically linked to the utest.exe. So indeed, it's exactly the same code and everything, but I get a memory leak in my heap. But there are really two memory leaks in this case. So therefore I have to call the free DLLs. And I have to make sure that that's valid. And it happens to be off by 10, so I subtract 10, and we should be fine. And it should be fine. but we have no way to tell because it doesn't print out any report about memory leaks. We could make it do that, and we probably should, but nobody else does. They use something called managed memory. Our memory is never freed, ever. You wouldn't have a function called deallocator that you'd have to call. You just allocate where it will keep allocating, and eventually it notices that some part of the heap isn't being used very much, and so it just deallocates it on the fly. I'm not sure what it does with the pointer, because if you did try to use that same address, I'm not sure what would happen. Okay, so we allocated 10 ints. How about instead of just printing them, why don't we add them up? I haven't mixed the for loop up to 10. I'm going to go to 9. Can't go up to 10. Right. Okay. Now where are we going to store that? We need another int. I'll just declare one on the stack. Here's the array. Here I'm setting their values. Actually, the 0th value is always 0, right? So we don't need this. That is the 0th value. And now, what about the case of 0? And that's fine. After the first time, it's going to be 1, right? And then it'll be the next will be 1 plus 2, and so on. Now, assignment or plus? Let's just do assignment first. What do you think we're going to get? Let's see. Since we're just assigning, it should be good enough to just do this. We don't need to loop, right? Now, here's p-ints. Well, that's okay. Right, now it's it's going to just give us the sum of whatever in each consecutive pair here. All we're getting are these odd numbers. And in the end, we get 17. Well, 17 is 8, 9. 8 plus 9 is 17. That's not very interesting. Let's accumulate these additions. Now you should know from what I've told you before. The sum is now I don't want to do this subtraction anymore because I've fixed it. What I can do to make sure of that is to put a const here. I don't want the ints to be const, right? But I'd like this thing to be const. Does that do it? It must do it, because if I put it on the other side, it won't. So this ought to be a syntax error. I hope it is. And these two. Definitely syntax errors all around. Okay, this should be fine. I'm not allowed to subtract anything from it, but I can change the content. Now that guarantees I don't even need this assertion anymore. Now this is guaranteed to always be the same value that I started with, so the deallocator function will be passed the correct value. That's why you would make something like that const. Not the values, because I want to fill them up, but the pointer. I don't, now I don't know how to say CP. I guess so. Yeah, that's a better name. Constant pointer. C in the naming convention applies to the thing to the right. So if it was constant int, if there were another const here, I would say CPC int. Constant pointer to constant int. Oh, now what is this? Oh. And I figured it out for me. Smart. I think it shows you the couple. Well, yeah, I guess it's not this playlist anymore. You can work this out without having to go through this walk in a single step. Oh, no, I'm doing something different here. This is a different sum. I'm not adding each item to the next. If you want something cool to tell people. Oops. 1, 3, 5, so far 6 with Reggie. 7, 9, odd numbers. No, the big jump there. 64. 81. Okay. Except the last time I don't want the comma, but I don't care. I don't know what this sequence is called, if anything. So it adds, okay, it allocates. Whether the free is working is an unknown. It doesn't tell us. However, it's possible to make the DLL tell us. That's a funny sequence. 9, 16. They're all squares. It's all the squares. Oh, I see. Okay, of course. And the sum is 9 times 9. This is 1 squared, 2 squared, 3 squared, 4 squared. Now you probably could have figured that out all on your own. Now, at this point in the video, I went on yet another diversion because I wanted to present for you this here sum and offer as a puzzle something for you to try and figure out. Okay, no, I may also upload that diversion. The diversion is a technical one. Turns out Gmail text got disabled on for my Gmail. But anyway, I have that. I've done a lot of snipping and clipping in at least 300 frames. I can put on mute. Contain the theorem. It's very easy to prove. The sum from 0 to capital M. I got this wrong. I have it right somewhere. Well, it's either off by 1 or not. If n equals 0, I get 1. That doesn't sound right. If n equals 1, I get 1 plus 3, right, which is 4. So this should have been n plus 1 squared. I thought I had that. No problem, I can find that. It's in here somewhere. I didn't manage to fix it up correctly. You see how much time wasted. Here we go. The sum from 0 to n of 2i plus 1 n plus 1 squared. Now that's something that you actually know, and you know it, and you've known it probably all your life, but didn't know that you knew it. But these diversions keep diverting me from my main point, the point I've been trying to get to. Now let me pause for a second, think about how I'm going to state the point as quickly as possible. Okay, well here's one go. Now we got this DLL and it's got all these various functions, okay? Now, so therefore the DLL itself represents a collection of functions, right? I mean, that's what it is. It's a collection of functions. Now this is the reason why I believe that the component object model originated from C++ ideas because of the following fact. If you had a DLL like this, now this is not the best example of the kind of thing that I'm thinking about. But one way that we like to, in C++, we write collections of functions this way. Now, I'm going to imagine a class that doesn't implement any functions, but simply defines what they are. Okay, just like dump in. Right? It's forgetting all this garbage. Here it is giving us a listing of some functions. It's also telling us what the arguments they take, right? And it doesn't tell you the return value, but good enough. Now in C++, that's easy. What you do is you say, let's call our class. Let's try and think of a problem, something that we would want to use this method for. Okay, let me pause again. Okay, here's an example. I want an interface that, and I'll use the letter I for interface, for the client side of an HTTP connection. So interface HTTP client. Okay. And we could use struct really. Make everything public except for one function. Now what I want this thing to be able to have are all virtual functions. Bool, connect. Now I'm going to use regular strings. We're going to have to support both Unicode and non. This would be, we're the client, and then we're connecting to a server. So that's the name of the server. And perhaps a timeout value. And we're not implementing it. Now, I have something similar to this already. I'll copy some of those. One of the things that you do if you are connected. Now, okay. This here client thing, right, doesn't have any data. So if this doesn't succeed, that it's tough luck if we start trying to do stuff with it. If it does succeed, we would consider this thing as being connected. But we could invent that, right? So we can always have a check and see if we're still connected. Now, one of the things you do is that get, right? And now we don't need the server name, that's internal. We might specify a web page on that server. Right, now the get has got to return something. It's got to return the contents of that page. We could either pass in a buffer, or we'll do it in a different manner. LP void, a pointer to, or even string if you want, but no, string, okay. Pointer to, it could be const star. Okay. Now if this thing succeeds, this would be initially null, and it's a pointer to constant data, but the pointer itself is not constant. and will be assigned a value from which we can read the contents of the web page. Let's say, if this succeeds, at the end of the day, we didn't allocate this. If we're not using managed memory, we'll need a free buffer, which takes a pointer to void. Okay, now here is an interface to an HTTP client that can open a connection with a server and read a page from, right? I don't have any send or anything like that. All right. Now, so this is an interface. Not implementation. That's just the interface. Now, here's the thing. In C++, we can do something like this. Get interface static. Suppose there were a function like that. It doesn't have to be a member, does it? Suppose there were such a function. And would it take anything? No, not necessarily. And it has to return one of these objects. I think we pass in well, okay, now here's the function that we would like to have. Hang on a sec. Okay, that's not correct. But bool is okay. How about that? Get HTTP client, which takes a pointer to an HTTP client. Alright. Now, if we had such a function, we could retrieve one of these and do all this stuff. Oh, one thing I forgot here, disconnect. Well, timeout. Right? Freeing buffers, getting contents of pages, and all we need is one of these things, one of these interfaces. Then we can use these functions. Alright. Now, I'm going to show you how in C++ this is trivial. And I'll use some DLL here. Now, this could either be another diversion or another video, but either way I gotta go through this. First things first, we're going to drop the def file. Check it in. Now I think I can just say that I don't want to use the raw configuration. Okay. Let's put that in its own thing. for unused stuff. Okay. Now here's our DLL main. This still has to be Win API. Now, it's not set up properly in our structure here, but it would be good if we had another folder here, not a test folder, not utils, but something like devices or something. Maybe I could make such a folder. Okay, and so like common, it'll have an H directory, and underneath devices will be various things that will implement interfaces that I'll put in this header folder. So we have our DLL here. I'll copy this. It doesn't matter what it's called. I'll call it my HTTP client, and this is all unhooked from everything, so I can put it here. Okay. Now, get rid of some DLL. Check it in, get rid of it. Here's a new project. This I can just get rid of. Delete. I should delete it completely. DLL main. Now, in here I need a header. I want a header file called http client.h. Text document. That doesn't have text. Okay, and I'm going to put this interface in there. Okay, so there's the interface, and this project configuration properties will include page. Is that the right number? Swap steps back. If I'm here, it should really only be one. Okay. It should be for all. Alright. Okay, I didn't do any of that. Whoops, oh, fine. Well, I need that header file, HTTP client. Now I'm going to define a class Whether it's public or private doesn't matter. Was I whatever it was called. I'll fix that up in a minute. And I'll have to implement all of those methods. I don't need my own header file, probably. This one file should be enough. I need a function like this. Less than 8. Okay. I'm going to implement that. That's a DLL export. None of this integer stuff. It's going to be a new one of these. Alright. Now, there's no def file, there's nothing. Now, what about implementation? Can I implement something? I'm going to press pause and try to implement a few calls. Or at least printf. Okay, we can printf like calls. Usually, anyway. The first thing you want to make is a dummy version that just prints debug stuff. Unfortunately, I can't open that file. Can I include it in the project? Probably won't let me. It's okay for now, but it'll get mad later. Source safe will get mad because it's not the right word. Okay, at least I can look at it. This is the interface that I meant to implement. So I copy all these functions. And implement them. Here what we could do is make it look like we're connecting. No, I don't have common or anything. I have Windows maybe. I need a console. I need to connect. I know how to do that. Alex did console. Well, apparently that does it. I need to free the console, but I might as well. So it's going to have its own console, whether you like it or not. We don't really need the standard in part. This is good. So what I'd like to do dot. I'm going to do this in a loop. Forget about the timer. We'll ignore it for now. We'll do what we're not supposed to do. Then we'll pretend we got connected. Implemented. We do a similar thing. Let's sleep a bit so you can see it. Okay, disconnecting. Let me do true. Check it connected. We need data. That constructor. Set it to 0. I think you see what's happening. Get contents, we can't do that really yet. What we can do is we can put something in there. Bytes. I have a file, several files. Locally, that could be used. I got my interim jump table. Okay, there's 137K. I need more. I need 1,000 bytes. I don't have get file. I don't have any standard functions. LP Easter P3 equals let's say 16,000 bytes. That ought to be enough for this file. print. Mode, read. And now we just need a small, but we could do it on one read. F read, buff size. I don't know how big it is. Okay, just make it small like that. Just read so we're done. Okay, buff. Count. Well, yeah. I never know what to put here. I think this is always no terminating. It certainly reads up to the character. It stops at character return. Sure, it starts out at 0 and 8. Concatenate. Wow. Okay. And that should do it. Not constant. Card. LP stir. 1,000 character values. We're assuming it's multi-byte. It's always multi-byte from the internet. Okay. It could be UTF-8. That's multi-byte. Now we're concatenating buff. Question is, does it always not terminate this thing? I forget. I always add one. Should have that last one is that. Track one from here. Now this thing returns null when at the end of file condition. Okay, we've implemented all the one more. Set that to phone. So one way to do it in one line. Okay. Alright. Now if this works, then we're left. Alright. Compile. Doesn't depend on anything. It exports exactly one function. I didn't say I don't want to do that yet. What's this? Star of pointer to pointer not equal to null. So this string, whatever it ends up being, the pointer to that string will be stored at the address pp content. No, what's wrong? Oh, it should be that one as well. And it's for the let's set it to that here. Error, not reference. Why do I have that? I don't even have a cert. Assume it works. Now the private member. You know, it doesn't matter. This can all be public. Nobody else can see it, right? It's private. I mean, nobody knows the. Well, I keep everything on one line. Okay, now the important bit is this. Didn't make it. It's true. No death out. Okay. Similarly, we don't want to live. And there's no lib in here. Okay, now this here put it into a file. Clipboard. I'll never fix this fun business. This here function name, right, is defines an interface a function that retrieves the correct interface. It's got the right name, it takes the right argument, right? And this is what its actual meaning is. And so we're going to define this in our header file. This is the function that retrieves the interface. We'll try and sound like pointer to function interface identifier equals this. Okay. So now if you load up the DLL and you find this function exists, then you call it and you can get yourself one of these. Alright? So I'm going back to utest. So I'm going to load that library. No, not that library. Well first, suppose I know the name of the DLL. Generally you wouldn't. You put that in the registry. Take that. Cool. Let's see that go. Alright. Get alright. I don't know how this is going to read. Now it's going to look more like type. Okay. Now, the class exists and is defined and is in the proper format and everything if and only if the following is true. First, we need to include that file. We can go like this. For now. An interface pointer, P, we'll call it fine, equals null. This identifier is used to certify that this is the right function. Now we can do stuff with it. If not, we'll return. We can try. Right. No, second time out. But do you see how C++, in C++, doing this sort of thing, it isn't even like, you don't have to think about anything, right? It's already designed to do this easily. This uniquely identifies the type of function required to retrieve an object of the specified type. The object itself, this implementation, this function, this wouldn't compile unless this my HTTP client were not the correct type. So it must have implemented all of the functions. You see, you can't go wrong here. Hopefully we won't go wrong. You tell. We can use clone. But you see, now this DLL, that's replaceable. what I'll do is I'll extract that from the range. These two steps, this and this, would be put off in another function that extracts the DLL name from the registry at a standard location, right? And in order to change the implementation, we just change the DLL. Okay. Okay. Now the library got loaded. Now this should work. There is such a function. Okay. Now I'm going to step over this. Okay, that succeeded. Now I'm going to step into this. You see where we are? So now we've invented com. Let's try and get a page. It's always the same page. Well, let's go take that string. Where's that string? And now I just need a pointer to any kind of pointer. It's going to do the allocating for us and fill the buffer with the content. Now, if this succeeds, I want to print it out. And then I want to free it. Getting the idea? Now, I'm going to use PTC page. Okay, a few bugs I just quickly fixed. We'll run up to here, connect into Google as we want. Now I'm going to step into the get. Remember, that's not using our mouth, it's another mouth. It should get to here. Okay, that's certainly the contents. Here it is. Okay. Now, I have code for doing this on the internet. Now, this should not complain. That's a valid pointer in this line. And everything's fine. Now, in a nutshell, that's com. The next, I'm going to show you how this idea has been generalized so that it doesn't have to be C++. See you.